Hello there, welcome to this new tutorial. So in this one, as I mentioned, we're going to do run the case outside now the workbench. So as you download the cases from the website, you have this workbench case, but also you have these files, now this zip file. So here you already have all the case, everything predefined. So see that you have the laminar case, turbulent case, everything ready to go. So see that you have the files as I mentioned. Okay, the ones, and let me change here. No, the .cast h5 and .dat h5. So here you have the mesh plus case setup plus the solution. You have the clean mesh, and here you have the setting file. Remember I mentioned this setting. So very often also I will put in some later tutorials, I will only put the mesh and the settings. So I put the clean mesh, so you do everything from scratch, but if you get lost at any point, you can use the settings. Also, the advantage of giving you the clean mesh is that it is independent of the Fluent version. So you are not going to have any more that requirement that you need to use the 2021. Okay, so you can use the MSH and the settings to set up everything automatically. Okay, so let's go here and let's run the case. We're going to go right ahead and run the turbulent one. Okay, the laminar nothing changed. Okay, so one small warning that, okay, let me launch Fluent. So see that first, previously we launched Workbench. Now I want to launch Fluent. So you look for the Fluent launcher, press there. See that we're not anymore in the Workbench. So this is a little bit different. So see, first thing here is that you need to select the dimensions. Okay, so this is a 2D case, double precision, processors as usual, and then you need to give the path where you are going to work. So I'm going to work here. So working directory, put it here, and start. Okay. So what I was telling that when you run laminar case, my advice is do not use turbulence model. Okay. So if you are sure, you are 100% sure that your case is laminar, switch off your turbulence model. Okay, so it is less computational expensive, and sometimes it might happen that the turbulence model might add a little bit of that black magic, the turbulent viscosity. So you might get some slight differences between the laminar solutions you have an analytical solution and the one when you enable the turbulence model. So be careful. That is my advice. Okay, so we're here and let's do. Okay, so see that now here the options, nothing changed. Okay, it's exactly the same. You have everything, but you are outside the bubble. You are not using all that memory. You don't have that graphical user interface. Okay, so this is lighter, faster, and I like to work like this. So this is the way I work. So for instance, if you want to read the clean mesh or this case, let me read the case and solution. So you go turbulent, press there. So I know that I have the solution, so I choose read case and data. So it's reading everything, and now you have everything here, and you do your post-processing. Okay, so you have all your data here, everything that you computed, you have it available. So you can plot monitors and see your monitors here. You cannot see this one. If you were plotting this one, you cannot see. You can see is those if you save the data. So if you save the data in a text file, you can replot it. Otherwise, you cannot plot it, but it's not a problem. Okay, so let me show you now how to read the mesh. So you see here how to read the case and the data. So let's see how to read the mesh and then read the settings. So to read the mesh, you go here, read mesh, discard everything that you have there. And this is the clean mesh. Okay, here you don't have any setup. You only have the mesh here. So now you need to do the whole setup. So remember everything that we did previously, now you need to do it here in the same way. But now we know that we have a setting files. Okay, so these setting files, we can read it. So remember that you access that setting file here. So let me talk a little bit more about this text user interface now, because here you have many options. Okay, so see that you have like report, you go into report and you have many options. So you have access to many advanced options. Okay, so you press enter. So for instance, summary will give you a summary and it will ask you sometimes. So it's telling you what you have. So see that you are in report. If you want to go back, you press type Q, enter, and you are back, enter. Okay, so here you have many options. So for the moment, and I think we're only going to use that one to read the settings. Okay, so that one you have it in File, enter, and it's called Read Settings. Okay, the equivalent to write is called Write Settings. So you have it here. Okay, so if you want to write your settings, write settings, it will ask you to give it a name, give a name, and it will save the setting files, and then you can move that file between different cases. Okay, so let me read this setting, read settings, and the name I know is settings, so just let me show you here. This is the name, settings, and see that it's reading all those settings. And now you are ready to go. So everything you have it there. So for instance, you want to write your settings, is write settings and give it a name. I will call it banana. You go back here, see that you have it banana. So now that file, you can move it to read your settings. So this being said, okay, how to, well, also to run, you initialize. Remember, before running, you initialize and then press here and it will compute your solution, okay? So I'm not going to run the solution, okay? I'm going to read, okay, the previous solution, case and data, and I want to show you some specific post-processing, this post-processing, because here see that we're computing y plus these quantities that are not computed by default. Okay, solvers that don't compute that one, you need to compute. So I'm going to show you how to do it in Fluent. Okay, it's a little bit tricky, so I recommend you to do it. It's better to do it using external applications. So in the 3D case, I'm going to show you how to do that. But we know our definition of y plus everything. So just to remind you how to compute and do these plots, you need to know the wall shear stress. So for instance, you need to choose one location. So I want to sample in this line normal to the wall. So you go here, normal to the wall. Remember, it's always normal to the wall. You need to know the wall shear stress here to compute the shear velocity. And also to do the u plus, y plus plot, also you need to know the distance from the wall. Okay, so from the wall to normal, the distance, and be careful, this distance you start from 0. Okay, so if you leave it like this and this dimension is 0.1, this plot is wrong. So always when you want to do these plots, sample shear stress in one location and then plot normal to the wall, but be careful, always the distance needs to be normal from the wall. So 0, 0, 1, 0, so I'm going to show you how to do this, but that is very important, okay, be careful. So this plot is similar, okay, but now to compute this one, we need the strain rate. I'm going to show you how to access that. And this is just trivial in here in this wall, just plot the wall shear stress, the velocity. So I'm going to show you also how to save this data, okay. Interesting in this case also, we're reading external data. So I'm going to show you, because this external data also follows on a specific format. So I'm going to show you this. But the interesting thing here is that see here that you have your theoretical correlations. And this is the output from another CFD solver. Different physics, I don't care. But remember, when you normalize everything, you should be able to reproduce this plot. Okay, what it changes will change. Different Reynolds, you have different logarithmic regions. Okay. So that's all. So I read the case, okay, you have the solution, and all those plots that you see here, okay, all that stuff you can do it here in results. Okay, just to show you in results, is you go now into plots, X, Y, here's where you can do all these plots. So let's see, these plots is there where you can do it. Okay, so just to show you, for instance, let me see here that I create many plots, okay, and I gave them a different name. So let me create a new one, new, and I want to plot, let's say in this line, line 10, I want to plot velocity. So see that this line 10, I know that this line go is vertical. So see that plot direction, you need to put it like this. Also, if you don't want to use plot direction, deselect there. So it's up to you. In this specific case, I know that I give there my plot direction. Important also here, no values. Remember, so you put here no values, you're going to get the the values in the nodes. You deselect cell center. So this is how you plot the data, or how you save the data, because also you can save the data here. So let me plot this first, okay, and see that you have it here. Okay, so the difference is I go like this. There is a slight difference because now you're plotting cell centers. Here you're plotting at the nodes. Okay, so it's up to you. Okay, there is no, theoretically there is no difference, but it's up to you. But let's say that you want to save this information in output files. See here, write to file. I recommend you to order points, write, and give it a name. So I will call it test out. See that it's saving this file here. Okay, so if I go here, remember this is the file it will save here. You open this. Here you have position in the line and velocity magnitude, okay? You have it there, and then you can do your plotting. So see, and very important, you go from the top wall, this is the top wall velocity 0, to the core that you have the maximum velocity. So remember that if you are doing the y plus stuff, this needs to be -1, so you start from 0. So this is how you do it, but also this data, how you see it in here, this is a very specific format. That is, you want to read data in Fluent, you need to follow the same format. So just, it's very intuitive. Title, label, X, Y, and then this one, just give it a name, and then the coordinate, X, Y, and close here with a parenthesis, okay? So have that in mind. Okay, so you can save that data. So now here you can choose whatever you want to plot. Okay, so for instance, you want to plot, let's say, turbulent kinetic energy. Whoops, I don't want to save. Okay, see that you have your plot there. You can change axis, curves, you have everything. So usually I like to save this data, and then you use like MATLAB, Python, NuPlot, whatever to do the plotting. It's up to you. So see that you have all this data, those plots, and you can do it there. So let me show you this one, the y plus, u plus versus y plus. Okay, so if I go here, see that you have the plot here. By the way, axis here, you can control minimum, maximum, logarithm, scale, everything. So see that you have the plot here. Okay, these quantities, see that are custom fields. So I compute these quantities from the solution. I will show you how to do it. I'm doing no values. Okay, see that I disabled this option because I put my axis. And for instance, you want to load data, see here, load, and here you have this ASCII validation data, and you choose this one. So let me choose this, and see that now this is a reference data, and you can plot. What I want to tell you, remember that that data is in the specific format that you saw when you write the file now. When you wrote the file. So see that I set up everything to have the same format. Okay, so that is the only thing, that you have your data coming from whatever program, Excel, I don't know, I don't care. You just need to post-process that and put it in this specific format. Okay, all these files, okay, I generate these analytical profiles also, and I put them in this specific format. So see that now, let me go and let me load this, and this. And you have everything there. Then you go curves, and you can change. For instance, you want to see this one for I don't want to see the points. I want to see continuous line, apply, and you have it there. See that we have a very good agreement. See, then viscous layer, then the buffer layer, and then you have the logarithmic region, okay, which is not very wide, but you follow that behavior. Okay, so this is the first validation, okay, important validation. Then we go, for instance, here, turbulent kinetic energy, the same plot, but see that now we plot it in function of y plus, and see that here it peaks, as I mentioned, as I told you, it peaks something between, in the buffer layer, something between 10 and 40, 50, where you have the viscous effect strong, you have it there. The same would be for the epsilon tolerance intensity. Okay, so you have all this plot here, and these are interesting. So these are the shear stress, the total shear stress. So total is laminar plus the turbulent shear stress. So you have this plot that later we need to put it together with the other to understand better. But for instance, look at the laminar shear stress is this one. So remember that laminar shear stress is important close in the viscous sublayer. See here, Y plus laminar shear stress. And then in the core is low. In the core, it becomes dominant, the turbulent. So see that here, the turbulent is the dominant one. So if you want to plot, for instance, this tree, if you want to put it in a single plot, see that you have here this option, data sources. And here you say add XY plot and choose the plot. I want this, this, and this. Okay, and plot. And you have the tree here. So now since we can understand better, see that the red plus the green one is equal to the total. So see here that close to the wall is the viscous stress. And then when you go away from the wall, you go into the buffer layer, see that your turbulence stresses start to peak. Okay, and it's the largest contribution. Okay, so this is a classical validation in pipes, but you can get something similar with different geometries. Okay, but very, very nice. So Y plus the shear stress there. Okay, so we're going to see how to compute those quantities. So let me go here. So see that this plot, this one we saw, this one. So wall shear stress in the wall, this one we saw. So the wall shear stress in the wall is also straightforward now. So for instance, let me go here, a new one. You select the wall. Usually you have wall fluxes, wall shear stress, and you plot it there and you have it. Okay. So we have seen that, for instance, we're doing this plot and see that I am selecting this line 10 to do the plot. How do we create that line? And better, we can appreciate that better if I look at the mesh. And let me change those colors, and let me, it's difficult to see there. Okay, probably here we can see. So see that the white line here are those lines where I'm doing the plotting. Here, 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 here. Okay, so I create many lines. Okay, to do the plotting. So how do I create? How did I create those lines? So because you can do plotting or sampling in lines, points, or faces. So you go here in results. See here, I created many lines. So if you double click in any of those, you give coordinates, a name, and that's all. So to create it, right click, new, and choose what you want to do. Point, line, isosurface, isoclid, you have many options. So the most important ones, you have it here. Okay, so probably this plane you will have it available because you need to be in 3D. Okay, so you go line, give your coordinates. So let's say that I want the line in 6.88, 6.80, almost at the end. I know that the end is 7. And it goes from -1 to 1. Not necessarily needs to be contained within the mesh, okay? So usually when you know that, put a large value, it doesn't matter. Create. And let me go back to mesh. And it should be here. So that line, should be one there. Okay, so this is how you create those lines. Okay, so feel free to create it. So here I created many lines, as you see. Okay, so different coordinates. Okay, so the one I'm using to do all the sampling is this one at 6.9. Okay, so this one that I just put is a little bit behind that one. Okay, so I'm plotting everything there. So how to do everything? So we saw how to save the data. So you put the line or the point, and then if you go here, XY plot, for instance, let me go back, this velocity profile, okay? So pick up that line, save the plot there. As you want to save the data here, save the data. So everything that all these plots, you can save that data. and use it in external programs or do the post-processing. The big question is, how do we create those fields now that we have new fields that are not computing by default in Fluent? Fluent computes by default a lot of stuff. So I invite you to go here and see all the options. So see velocity, these are all the fields that is computed by Fluent. You go here, pressure, you go here, for instance, mesh. These are the coordinates. So if you want to access coordinate, you have it there. You have wall fluxes, wall shear stresses, skin friction coefficient, properties, molecular viscosity, derivatives. So see here that you have a strain rate. This is the one that we're going to use for the shear stress, and you have all these derivatives, and you can create many more. Okay, so to create customized fields, so first see here, you go here. I haven't mentioned anything about reports. Let me mention something a little bit. So here also you can compute, for instance, you want to compute fluxes, you go there, inlet, outlet, mass flow. So inlet, outlet, and this is imbalance, this minus this, okay? And you want to compute forces, you wall, then give the direction vector, force, moments, whatever, surface integrals. So see here that you can say, I don't know, at the inlet, you want to compute, I don't know, whatever. So you have all these options, and everything that you created, you can access here, okay? So you created custom fields, you can access and compute that, and then you can compute these quantities, okay, using also the primitive fields computed by Fluent. So very powerful, a lot of post-processing you can do. But what we're interested in computing these Y+, those new fields. So if I go here, see here that you go below here, parameters and customization. See that you have this new tab here, custom field functions. Here's where you create those custom field functions, okay, created by the user. So they are not computed by Fluent. You as a user can compute this. So see that I compute all this. So to create a new one, right click, new, okay, or to manage this, let me click in manage. So see that, for instance, let's see first. Let me show you the first one, height. So see that here, height, I computed the height, y minus 0.05. But if I use this one, I get negative value because it goes from 0, okay, to the value. So I'm getting negative value. So I need to use absolute value, okay? So you have the functions I will show you. You can access. This is the coordinate. So absolute value of y minus 0.05. So see that this is the distance normal in a point, okay? So then, for instance, shear velocity. I know that shear velocity is the square root wall shear divided density. So you compute that quantity. Then, for instance, the y plus 2 is equal density times height. Height 2 is the one that is the right one. No, at that point where I'm going to plot this y plus, it is 0, okay, times shear velocity. So this is the shear velocity, okay. So I put the value there, and here the laminar viscosity. U plus is just velocity magnitude divided shear velocity, okay. And then here you have shear stress. Laminar is strain rate times laminar viscosity, shear stress turbulent strain rate times turbulent viscosity, and total shear stress laminar plus turbulent. So let me show you, let's review this one. Let me show you, for instance, how to compute this one, the shear stress, okay. So as you go here, new, you need to put select the function. So for instance, the strain rate, I know that I have it here in derivative. Strain rate, you select times, and let's say times properties, molecular viscosity. Okay, give it a name, test2, define, and you have it there. So now you can access this field. Okay, so you go manage, okay, you can see the definition, okay. So for instance, let's redo height to this one, okay. So if I go here, new, so that one will be, okay, remember I want absolute value, put parentheses, and I want y is here in mesh, x coordinate, define select minus, I know that it is 0.05. You close and call it, give it a name, okay? And I have it there, okay? And so on. So to visualize those new fields, you just go here and you have it in custom field functions. So you access those fields. So for instance, this one is the latest created and you can compare with the other. So you get the same, okay? Then the laminar, this one was the laminar shear stress. And for instance, let's do Y plus value, okay? So see that the Y plus value is the actual definition, okay? Density times height times the shear velocity at that point. So remember that I'm doing this sampling at 6.9. So at 6.9, I know my wall shear stress. So how do I know that wall shear stress? Well, what I did is that, for instance, two ways. So you can get here in this monitor. So see that I, in line 10, write that information. So there in your files, okay, ASCII out, I already put the output here, but for instance, I already saved that information there. So you open this one, you see that at the wall, this is your shear stress. Okay, so this is in the line normal, but also you can do it in a line along the wall. So I save it also in a line along the wall, so it's 6.9. Okay, so that is how I sampled that shear stress there, okay? Be careful when saving the data. Now, you need to know if no center or cell center, okay? For the moment, it doesn't make a difference, but later if you want to do something more advanced, it will be important to know where you are saving that data. So this is it, okay? You save all the information. So as you go here, for instance, new, and let me create, so it will be, remember, it will be density. So let's go, density times, it was a custom field, okay? It was height, this one, times the shear velocity, okay? That I don't recall what was the value, so I will put here, I know, 1.23, okay? Doesn't matter, okay, del. And that divided properties. So that put, and you have it there, okay? I didn't give a name, you use that name. Then that you have that, you can do your plot here. So you can create your new plot. I go here just to show you as well. So I want to plot, okay, here. So I want in the x-axis, I want to put there, let's say the y plus this one that I just created. That it makes no sense now, but just to put something there. And then I want to put here the u plus. Okay, I put it there, and the sampling is here. You need to select the line and you have it there, okay? Then axis, because x should be logarithmic, and you have it there. Okay, so this is how you do those plots. Okay, so I think I covered everything. So then you can save all this stuff. I show you can save all that stuff in ASCII file, and you feel more comfortable doing these plots in using MATLAB or Python, do so. So if you want to do it in MATLAB or Python, the only thing that you need to save in a line, so you see that in the folder, you see ASCII output. This is the output that you need. L10, here you have the velocity in that line, okay? And then here you have the shear stress. So this one, WSL10 is the shear stress in the line normal. So just the last point. Or if you want along the wall, is this one. So this is the only information that you need. Actually, you just need this. And this one, you will put it there to compute the shear velocity. And then using Python or MATLAB, you can do your plot. So this, I prefer to do it externally, that in the 3D tutorial, we're going to do it, okay? So I'm going to save these files, and using Python, I'm going to show you that. So I think I have covered everything, okay, regarding this one. Again, go back here and you can see your colors, everything. So just revisiting this one, that is a wall resolving. Close to the wall, you have this one. And remember that you plot the turbulence quantity, turbulent kinetic energy. Close to the wall is 0. This will be somewhere in the buffer layer, okay? And epsilon also to the walls start to dampen everything, okay? And then turbulent viscosity, okay, you have it there, okay? You have your turbulent viscosity. And also you can access, for instance, production. We have seen what is the production term, okay? You can access production and see where the turbulence produced, okay? So you need to do at least one iteration to access that field, by the way. So let me do an iteration because it needs, I initialize. Oops. So let me run a few iterations, and now here. So see that now you have the production there, but needs to run much more. Let me reduce 0.1. It needs to run for longer time. Okay, see where you have the production. Any case, so this is all. So thank you for your attention. At this point, then the next tutorial will be exactly the same in 3D. So I'm going to focus geometry, mesh, and then all these steps that you have seen here. I will go a little bit faster because we know what is happening. So this is all. Thank you for your attention. See you next video. Bye.